Hey everyone, welcome back to our channel dedicated to Microsoft Fabric. And this is the special series about data integration, data engineering, and data science within Microsoft Fabric. Today, Misha joins us to discuss data science capabilities and a super popular, fancy, and useful topic, which is AutoML. Misha, thanks
Hey,
for joining.
everyone. Hey, nice to meet you. Thanks for having me.
So let's start with AutoML. What is AutoML?
Yeah, so AutoML, or some of you might know it as automated machine learning. It's a really cool technique which allows you, whether you're a data scientist who wants to quickly prototype models or quickly build models, to an analyst who really, you might not be familiar with every different kind of model that might exist, but it's a way for users to really explore all the different kinds of models that might best fit their data set and to kind of help automate some of the process that's often very time consuming about tuning a model selection. So again, really simplifies some of the machine learning process and allows you to quickly kind of get started with building machine learning model and being able to deploy it into production.
Automated machine learning. It means that, okay, I can provide the data and tell me what's the model, right?
Yeah, exactly. So automated machine learning can support a lot of different tasks, right? Things like regression, forecasting, classification. And so the idea is really simple, right? You take a data set, you have your data, say it's sitting in Lakehouse, and you want to be able to fit an automated machine learning model or an experiment on top of it. And so all you really have to do is you have to say, hey, here's my data, here's the task that I want to do, give me a model. And again, if you want to provide more, granular constraints or more granular requirements, you can do that, but really it's not required. And the idea is to make it super simple for you to be able to set up and kind of iterate through a bunch of different models that might be relevant for your data.
And what's the building stone for AutoML in Microsoft Fabric?
Yeah, so what we've done, we've taken a open source project called flaml. It came out of the Microsoft research teams a few years ago. And what we've done is we've taken it and we've deeply integrated it into the Fabric ecosystem and the data science experiences. And so a lot of the things, like if you've used flaml locally on your machine or if you've installed it from PyPy, you'll find that it's actually pretty similar to some of the experiences that you'll see in Fabric. We've done some additional work to deeply, better integrate it into Fabric. So there might be some special things that you see in Fabric that you don't see in the open source. But again, there's gonna be a lot of similarities, a lot of things that you can leverage as you move from one to the other.
That's the open source, similar to Apache Spark, that we also pull OSS version. And again, if there is opportunity, we also contribute back. In terms of models, you mentioned regression, classification, time series prediction. And what are the models supported by flaml, by AutoML in Microsoft Fabric?
Yeah, so some of the things that we've done as we've worked on deeply integrating flaml into Fabric is we've added support for a lot of different kinds of learners. Some of the things that we've added are a lot of breadth across all the different kind of Spark learners, and so typically a lot of like machine learning libraries like scikit-learn will work on a single node. Spark is great if you have a large data set you want to scale out some of your training, and so we also wanted to build an AutoML or kind of enhance some of the AutoML experiences to better support Spark, and so a lot of support for Spark-based learners, a lot of support for models like Prophet, Arima, things even coming from scikit-learn. So a lot of the library frameworks that you might already know about. I can also share a link to kind of some of these different models that exist. So if you go up to the Fabric docs and click the automated machine learning section, one of the sections that we have is what we call our supported models. So here you can see all of the different kind of learners that we support in flaml. And again, like you mentioned, we've added a lot of different support for Spark-based learners. And so you'll see that this set of libraries is really comprehensive and probably one of the most comprehensive sets of learners that are supported in AutoML.
Again, classification, regression, and the third category is time series forecasting. So it's showing beautifully that in Fabric data science, we focus on running those models, those algorithms on top of the tabular data that is coming from Lakehouse, and it's natively integrated.
Yes, exactly. Yeah, a lot of good kind of work to natively integrate it. So, one of the things that we'll show on in the demos will be things like if you're looking at the models and experiments, these are first class items that we have in Fabric. And what we've done is a lot of work to deeply integrate these AutoML frameworks with these artifacts. And so you're training a bunch of models, you want to be able to see all of the different kind of iterations that have been created. Flaml in Fabric really enhances some of these experiences and lets you kind of visualize and see all of these different changes as well.
Okay, so I can connect with data from Lakehouse. I can use just a flaml as AutoML. Flaml will find the best model. It's natively integrated with, I assume, that Mlflow as well. And
Mhm.
at
Yes,
the end,
exactly.
I will get the result. The result is that this model achieved the highest accuracy, whatever the definition for the accuracy for the given task is. But accuracy for this model is the highest one. Okay, is that integrated also with a way to deploy this model to production?
Yeah. So one of the things that we've done is also, as you train all of these different models, as AutoML comes back with all the different iterations, it will automatically capture things like the metrics, the parameters, the schemas, and also all the different model files, right? So that's a really core part of Mlflow is how all of these things get automatically captured. And so with the integration with Mlflow, with how all of this metadata is captured and synced into Fabric, this lets you automatically then consume these models using Fabric Predict, right? And so the same kind of interfaces that you'll go through to walk through how you want to find your lakehouse, set up your prediction tables, you can do those on top of any model that's generated from flaml as well.
Awesome. Wanna see the demo? Let's go.
So now let's take a look at how you can use automated machine learning or AutoML within your Fabric data science workspace. Now, before we get started, one of the things I would like to highlight is that you'll be able to find all of this demo content directly from your Fabric workspace. You can do this by picking the samples gallery, navigating to quick tutorials, and then selecting automated ML or the automated machine learning tutorial. So let's get started. So in this demo, we'll take a look at a step-by-step guide that walks us through a few different automated machine learning scenarios and how you can use it within your Fabric Data Science workspace. Now, one of the first things that we'll do is we'll load our data. Our data contains the churn status of 10,000 customers and includes the attributes of things like their credit score, the geography, the number of products that they've used, and most importantly, our prediction variable, whether or not they've exited the bank. So one of the first things that we'll do is we'll load our data. This will be something that we'll make available now for us within our lakehouse. Once we've loaded our data, we can make it available to us from a Spark-based data frame. So here we'll just load our data using spark.read option. Next, we'll take a look at exploring and pre-processing our data. And so here, using the built-in display commands, we can start exploring the distributions of various attributes in our data set. So here we can look at things like the distribution of the credit score field and look at where a bulk of our distributions here might be. We can also look at things like the is exited field. This is our prediction output. And here we can see that our data set is highly skewed towards customers that have not exited the bank. Now, once we have a better understanding of our data, now typically part of the machine learning workflow, this is where you'll start doing your data pre-processing, your cleaning, and feature engineering. To help us clean our data, we'll simply remove some duplicate columns, remove duplicate rows, which we no longer need. Once we have this, we'll then generate some additional features on our data. And so here we'll take our geography column and go ahead and create some dummy variables using one-hot encoding. Finally, we can display our clean data, looking at all of the different attributes that we've added to make it available and ready to use for machine learning. Now, before we move on to the next step, we'll simply save our data, our final clean data, to the lakehouse. This is great because it allows us to reuse our clean data for future model training scenarios. Now let's move on to training our baseline model. Once we have our data in place, we can now define a baseline model that we want to compare against for our automated machine learning scenarios. So the first thing we'll do is we'll load our clean data set and we'll generate our test and training data sets. Now let's get into how we want to actually train and start tracking our results. Now, like all other Fabric ML items, the key integration point here is going to be around Mlflow, and this lets us track and log all of the different metrics, parameters, and models that are generated in our machine learning workflow. And so here I'll use the Mlflow auto-logging capabilities, and I'll set the experiment, which will allow me to compare and track all of my different results. Next, we'll train our baseline model. And so here I'll wrap my training functions all within the mlflow.startrun command. This will tell Mlflow or tell us to start tracking some of the results that we're seeing in our model training process. And so here at the output of our training process, we'll log the ROC and AUC score. And so here we can see that by default, our baseline model achieves an ROC or AUC score of 84%, which is pretty good for a model where we didn't have to do a ton of training. But one of the key things here is that in this training example, we're starting with the learner. Oftentimes, as part of the machine learning workflow, you might not know which machine learning algorithm you might want to start with. You might also not know how to tune or what's the best way to explore the set of hyperparameters for that specific model. And so what automated machine learning takes care of is really abstracting and simplifying this process of model selection and tuning. And so let's take a look. So our first thing will be to create an AutoML trial with flaml. Now, flaml is an open source library that came out of Microsoft Research a few years ago. And what we've done is we've deeply integrated into the Fabric runtime and the Fabric experiences. Now, one of the first ways this has been really integrated into our experiences is through its support for Spark. So here what you can see is that we're going to create an AutoML Spark trial. Here, we're going to set our task to be a classification task, right? So in our example, we are trying to predict whether a customer will exit the bank or not. So really, this is a classification problem. The other piece that I'll have to provide for my AutoML configurations will be the metric I want to optimize against. So here we've already decided we want to use the ROC-AUC score. And then finally, I can provide a time budget. This is an optional parameter, but really just tells my AutoML trial what's the total running time I want to use. Now, one of the key things here is that we're going to be using a pandas on Spark dataset. Now, this is still a Spark-based data frame, but what's really unique here is that it allows us to use standard pandas-based operations or pandas API looking operations on top of our Spark dataset. Now, once we have our dataset in a pandas on Spark data frame, we can then start running our AutoML trial. So again, this AutoML trial is running on a Spark-based data frame. And because of this, it's going to explore the corresponding Spark-based learners. And so here you can look at our AutoML trial. It had tried two different kinds of models. Both of these were light GBM models with slightly different hyperparameter configurations. At the end of this, our AutoML trial was able to achieve a final model which had the ideal or the highest score for the ROC-AUC being about 84%. So again, really simplifying some of the API surfaces that we had to include. I didn't have to provide a bunch of code on how to train the model. All I had to do was simply provide the task, the time budget, the metric, and let AutoML take care of the rest in terms of finding the model and giving back some of the best results. And we can then start inspecting the results of our best model, right? So here we can look at the configurations of the best model, the final metrics, how long it took to run. But here we can see that we're able to quickly get really great results with just a few lines of AutoML code. Now in this next example, we'll take a look at how you can use pandas to parallelize your AutoML trial. Now in some cases, your data is not going to need Spark scale. Oftentimes you might be working with a data set that can fit into a single node, and oftentimes you might be using pandas to help you do this. Now, one of the key things here is that the way we've integrated AutoML with pandas with Spark is that we want to make sure that you can make use of your full Spark cluster. So what does this mean for you? If you're using a pandas-based data frame, what this allows you to do is use your entire Spark cluster and make it available to run multiple trials at the same time. So here you can use your whole Spark cluster by simply specifying the number of concurrent trials and by setting use Spark equal to true. And this is great because you're not using your resources or your entire cluster to run one trial at a time. This actually allows you to make use of your entire Spark cluster. And so here again, with our mlflow.startrun command, I'm going to run our AutoML trial. And what this will do is it will allow me to track all of the different results that have been attempted in my AutoML process. Here, I'll be able to select between various performance metrics, various hyperparameters, and really start comparing between my trials. Here, what we can see is that using the pandas-based data frames, we'll also see that it's using single node algorithms or single node learners to explore my data set. Now, one of the last things I want to highlight is something new that we've added in to Fabric specifically, and we call this flaml visualizations. Now, this is a unique module that we've integrated into Fabric, which allows you to get easy access to a wide range of hyperparameter and AutoML plots. And these are really tailored to helping you better understand your AutoML and tuning process. And so in this case, I can use a feature importance plot and understand what kinds of features are driving my final model behavior. And so here I can see things like the number of products, the balance, the age, geography. These are all features that have a high importance in my overall predictions. Finally, I can view my model metrics and the results of my final AutoML run. These are the results of my best model. And what we can see here is that, within a short amount of time, we're also able to get pretty comparable results, especially now that we're using a single pandas data frame and running all of these different trials at the same time. Now, one of the last things I wanted to highlight here also is how we've integrated all of these Mlflow automated machine learning capabilities within our Fabric items. And so here what you'll see is that within your Fabric experiments, these are items within your workspace, you'll see that all of the different runs and metrics will automatically be tracked. And so let's take a look. Now, within my Fabric experiment, what I'll see is that even within my AutoML trials, we'll see that certain metrics like the run metrics, the ROC, the total running time, as well as various parameters and input-output schemas, all of these things will automatically be tracked. I didn't have to write all of these pieces of information into my code. Using the integration that we have with autologging and with Mlflow, all of this is automatically captured for you. And the reason this is really helpful is that when you then want to operationalize your model, you don't have to worry about collecting all of these different pieces of information. This is automatically available to you. So now once I go ahead and I save this run as a machine learning model, I can then jump over to my machine learning model itself. This is another item that we have in Fabric, which is where you can start some of your operational activities. And what I can do here is that I can easily select this model version and say, hey, I want to apply this model version and generate predictions off of it. And with that, you can see that with just a few clicks, you can now make AutoML models available for batch predictions.
Wow, that's amazing. Now I want to ask and unpack elephant in the room. What's the stage of this feature? How I can access it? Is it GA ready?
Yeah, so this feature is currently in public preview. So it's available in all regions. As long as you have a Fabric capacity, you can be able to access flaml and the AutoML functionality that we have. One of the things that we've done is it's also built into the runtime, so you don't need to install the library. You don't need to worry about configuring anything else in your Spark clusters. It's already available. And so all you have to do is pick a runtime that's available on Spark 3.4 and above, and you can automatically easily get started with your machine learning process.
Awesome. Runtime 3.4 means is equal to runtime 1.2, which is the latest GA runtime version. Right now we ship 1.3 as public preview. Soon we'll name it as GA once it has the GA scope. You mentioned Fabric capacity. In case if I have a Power BI premium capacity, does this feature also works for me?
Yeah, you should be good to go.
Awesome. And what's the timeline to the GA stage? In case I would love to use it for production-ready solution.
We don't have a GA timeline to share just yet, but we do have a lot of enhancements that are planned for AutoML and integrating it even further into Fabric and simplifying some of the experiences. And so definitely stay tuned for some of the upcoming announcements that we'll have in the next few months.
Awesome. All right, that's all for today. If you enjoyed this episode, be sure to hit the like button, subscribe, leave a comment, question, reach out to us directly. And Misha, thanks for joining. Thanks for sharing. I'm looking forward to record more episodes about data science.
Thanks for having us.
And until the next time, happy exploring and solving machine learning problems with just AutoML.